to look at domain given the equation. Okay, remember that this word analytic means given the equation. Okay, and remember what domain is the numbers that you can plug into a function and get something out. And so we're going to start actually with polynomials, and from there we're going to look at some other types of functions. All right. Now, talking about polynomials, what is a polynomial? Polynomial can contain constants, it can contain coefficients, variables, and whole number exponents. So it can have all of these things as a polynomial. What it cannot have is variables whose exponents are not whole numbers. That is not allowed. So if the exponent is 1/2 or -7, anything that's not a whole number, 2.5, not going to be a polynomial. Of course, anything that looks weird, if it has a radical sign or like radical x minus 2 or something, that's not a polynomial. Trig functions, log functions, and there's many types of functions. Those are obviously not polynomials, and the exponent cannot be a variable. Those are called exponential functions. So let me ask you, can you think of something, can you think of a number that you cannot plug into a polynomial and get something back? Think. Well, the answer is no. Okay? In fact, you can plug anything into a polynomial and get something back. So the key here really is to identify if it's a polynomial. Let's look at example 1. So the first question is it a polynomial? Well, we got 3x squared, 2 is a whole number exponent, minus 6x minus 7. Yes, it's a polynomial. Whole number exponents, okay, and nothing else weird. So the thing is, since you can plug in anything and get something back, the answer is going to be, well, first of all, yes, it's a polynomial. That's step 1. Step 2, the answer is going to be all real numbers, okay? You can plug anything into a polynomial and get something back. And for this particular example, I'm actually going to show a few things. So 3x squared minus 6x minus 7. Let's take a look. We're going to kind of test this with a few numbers. You can choose any number you want to plug in for x, okay? And think about this, okay? So you get to choose what you want to plug in right here. Whoops, right here, okay? You get to choose what goes in there, but think about it. No matter what you choose, you're going to get a number back, okay? You're going to get something back. I'm just going to choose, well, actually, I'm going to leave it up to you. No matter what you plug in, you will get a number back here. It's not going to tell you undefined if you plug into a calculator. You're going to get a y value back, so therefore, no matter what you plug in, it's going to be part of the domain, and that's why it's negative infinity to infinity for the domain. Example 2, on the domain of f of x. Well, this one looks a little weird, but let's take a look. The exponents are whole numbers, right? And then, of course, the coefficients can be whatever they want. So this is an actual polynomial, and since it is, we can write the domain is all real numbers. It goes from negative infinity to infinity. Again, another way of writing that is writing this symbol right here, which means all real numbers. Okay, you could actually write x because domain is x. All right, let's look at this example. Find the domain of g of x. Is this a polynomial? Well, actually it is, because it's a constant number, okay? And you could put x to the 0 after that, or yeah, x to the 0, but it doesn't have any exponents that are whole numbers, and it's a number itself, which happens to be a polynomial. Now the thing is, no matter what you plug in for x, you're always going to get 0 back. So it is a polynomial, but it doesn't matter if you always get 0 back. The point is you get something back. And since you get something back, everything you plug in is part of the domain. What you can plug in and get something back. So therefore, you're going to get 0 back no matter what. And the answer is all real numbers. For example, that kind of confuses some students, but let's rewrite the f of x equals 0. Okay, let's say that you decide, hey, you know what? I'm going to plug in 4. Okay? Well, guess what you're going to get back? You're still going to get 0 back because it's always equal to 0. But that's okay because you plugged in a number and you get something back. You can plug in anything for here for x and you get something back. You'll get 0 back. So therefore the domain is negative infinity to infinity, which like we said was all real numbers. So the gist of this lesson And the key is to identify the fact that it's a polynomial, and you'll be good to go, and you'll know that, hey, the domain must be all real numbers if it is indeed a polynomial. If you have any questions, other questions about this lesson, let me know.